Greetings! Today I was inspired by this pile of garbage clock that I took apart recently, and I've decided to reuse the chip on here that's responsible for audio amplification, the D2822A, and build the world's smallest boombox. I mean, it will have to be the world's smallest boombox, 0.1 of a watt. This thing will move some air, I'm telling you. But let me show you what I've come up with. Here is the schematic. As you can see, there is not much to it, and just an audio jack taking any audio signal that we put into it. There's a few resistors, capacitors, and the YD2822A, the little circuit, the little IC over here, and a few more caps, and to the output to the speakers. And that's all there is to it. I've also added a micro USB jack for powering this up. I'll have to suck it out from here. And the speakers, I do have suitable speakers for this, and those came out from an old laptop. And look at those monsters. So this will do just fine. Those say that they are 1.5 watts 4-ohm speakers. That will be fine with the power outputs of YD2822A. Let's put this together. Now, to do that, I'm going to use this PCB, which I've already printed out on a photo paper, and I just need to transfer it onto a piece of copper-coated board and etch it out. To etch this, I'm going to try today something new. Well, it is a Randomtronic channel after all. I've recently come across a number of videos showing a PCB etching method using a sponge. So the idea is you put a little bit of ferric chloride onto the PCB and then rub it with the sponge, and the sponge quickly removes any oxide from the top of the copper, thus accelerating the etching speed quite significantly. So I've seen some videos showing a fully etched board in under 2 minutes. So let's see how that works for us today. So after properly cleaning the board and cleaning it again, preparation is everything for etching PCBs at home. It will be the usual of sticking the copper onto the film, which is the cheap photo paper. So far I've tried a few other things, and some of them work really well, but this works the best. So let's put this on here and use some blue masking tape because it leaves a lot less residue to hold the board in place. So let's just make sure it's aligned perfectly. In it goes. And this should be the last pass. And if I just cut the tape around, let's see how it turned out. So perfect, as usual. This paper works really well. So now time to etch this, and to etch it we're going to do the sponge method, which I've never done, never tried before, but it's supposed to be really quick. So let's put it to the test. Here goes nothing. So first I need to affix the PCB at the bottom of the container, like this, with just a piece of masking tape. And I've got some fresh ferric chloride solution in just a small box. The beauty of this method is you need only a little bit of ferric chloride. And I've made myself a little tool, which basically is a sponge stuck to a suction cup with some glue, and then a stick stuck onto the suction cup with again some glue. That's just so I can move it around, you'll see in a moment, and I don't get dirty on my hands. You could use just a piece of sponge. Here's a prototype of a piece of sponge on a piece of wood. That could work as well, but I like this better. So let's put some ferric chloride onto the board. Okay, about this much should do it. And we should be rubbing it with a sponge. continuously, and that should accelerate etching process quite a lot. And we're using just a small amount of ferric chloride. I'm going to do this in one shot on purpose. If it gets boring, I do apologize, but I want you to be able to gauge how quickly will it take to etch this board completely out. Now, so far, all the copper is still there. There must be less of it, but it's still there, so I can't tell so far any difference. I guess the idea behind this method is that the sponge will remove the copper layer, the oxide, the copper oxide from top of the copper, exposing fresh copper and accelerating the etching process. Oh, wow, okay, in the middle the copper is disappearing already. Not sure if you can see, you should be able to see, yeah, the middle tracks have completely etched already. It seems like the wider traces, like the edges that I've left, are taking a little bit longer. Okay, I'm going to add a little bit more of the ferric chloride. Just a few more drops here and there, because I think we've just about used up all the little amount that we've put on. It was less than 5 milliliters that we've put on there after all. And the thing about this is, once you're done with this, the ferric chloride that you've used is pretty much spent. So you're always working with a fresh solution of a ferric chloride, which is nice, I guess. Which means it's always at full strength. Okay, it is quick, but I think I'm using far too little ferric chloride, so a little bit more. I guess the board could be etched in anyway. I could have just stuck it in the Seno bag and it would have taken 15-20 minutes, and maybe less than that, but yeah, the ferric chloride in the bag is quite spent already. It could be that I've made the ferric chloride not at full strength. I was just eyeballing it into the little bottle. I was adding the granules and then adding some hot water. I'll try to make it stronger next time. Okay, we've used up about 10 milliliters so far. When I saw this on one of the videos on YouTube, it went a lot quicker than this. But again, it could be the strength of my solution. But I can see the logic behind this method. It does accelerate etching. I guess the key is to have the right amount of ferric chloride for the amount of copper that you want to etch. I can see I might have a small problem on the USB connector, so while I can, I'll try to fix the problem. And that's pretty much done. And here's the board after etching. It turned out quite nice, and yeah, the method does work. It does accelerate etching. Maybe my solution was a little bit weak. I was expecting this to happen a lot quicker than it did in reality, but nonetheless it etched the board quite nice. And here is the board etched and drilled, and with a bit of a silk screen for the description for ease of assembling. So far so good, with one exception. The footprint for the micro USB port is different to the one that I've managed to find, and I can't find the one that would match this. I didn't check it prior to etching. Oops, not a big deal. I'm going to, instead of micro USB, I'm going to put in a cable through with a USB. That will do it. So let's get all the parts out of this that we need for this and get them transplanted. So first we need the power amplifier IC. Power, lots of power in this. There we go. And that can go straight into here. Like this. Ready for soldering. Next we need some capacitors. There is a 470 microfarad on a very long legs, so I won't bother the soldering it. I'll just cut it out. 1 and 2. That's 1. They left very long legs nicely. So we've got two 470 microfarad caps, which we can put in. This is the filter cap, and we've got 2 over here. I'm going to actually see what else have I got. What else do I need? 100 microfarad caps. That's 220 and that's 220. Okay, let me have a look what I've got in the junk pods. Before we reuse those electrolytic caps, it's a good idea to check them for ESR. I've managed to find a couple of 100 microfarad caps, so let's check this one. Yeah, less than an ohm. Yeah, it will do for this. And 1.4 ohm, a little bit high. Okay, let's check the ones that we've pulled out. Okay, this one's good. 0.07, 0.09, so those are good. I've got another big one. I'll use this for the filter cap. This is a Lilon cap, so I predict it will be good as new. Yeah, 0.03 of an ohm. So those are not so great, so I'm going to look further. Okay, that's better. 0.38 of an ohm. Not brilliant, but will do. 0.49, that will do. So we've got all the electrolytics, so we can stuff them right in. So this I'm going to use as the filter cap. Those 2 are going here on the output of the amplifier. This is how you can play with electronics for free, because most of the junk were almost for free. We did make the board, but majority of the stuff we've salvaged. That's all done. We need 200 nanofarad capacitors and 4 resistors, and the audio jack, we can stuff it straight in. I've desoldered that from something a long time ago. I can't remember what it was. Okay, there we go. That starts to look the way it should. And here the 100 nanofarad capacitors, I'll just use those ceramic disc capacitors. I've got a whole bunch of them anyways, so I don't have to look for them. Okay, that's in. 100k resistors I couldn't find, but I'm putting in 82k resistors, or 86. That was the closest value I had in my parts. And 8.2 ohm resistors. Again, I didn't find, but I've got 6.8. So that's close enough. That's not mission critical. The actual schematic called for 4.7, but then my speakers are slightly lower resistance, so I thought I'll increase a little bit those to compensate. There we go. This is now all populated. Now I'll just have to solder it up quickly. Okay, first I'm going to add a little bit of flux everywhere. Let's get it soldered. And then the power cable. I'm going to solder it directly to the filter cap and put a little zip tie. to stop the cable from ripping out. What is left now? Well, actually what is left now to push the audio socket back in, because I think it must have moved a little bit during soldering. Now the speakers, and they are going to go in like this. Now I've drilled up the holes a little bit, and unfortunately I have managed to crack the PCB over here. That doesn't matter really, but yeah, that's how the speakers will mount in, and the screw will go on top. So I'll just put a washer on there. I should have drilled those holes before cutting out the side panels, but that's okay. And yeah, I've got 4 screws. Let's get this assembled. And there we go. This is what it looks like so far. And now connecting the speakers. So I just want to trim the cable a little bit long, but on equal length. So like this. Split the cable and strip the ends. And now we can stuff it into where it should go. And this, ladies and gentlemen, is complete. So now let's hear it. So I just need to find our audio jack cable and connect our source of sound. Right, here is the setup. Music connected through a long thin cable here. This connected through a power meter. 5 volts from the power bank, just under, not drawing any current when music is not playing. And, ladies and gentlemen, the smallest boombox in the world. I assure you this is playing right now. This is just about as loud as a mobile phone. It's an old laptop speakers. But it was fun to make, because as always the joy is in the making. So well, I guess that's it for this one. Project successful. I'm surprised it didn't end up in a more mess as much as usual. But thank you very much for watching. Hope you enjoyed it, and I hope I've inspired you to pull out some junk and turn it into something else. For this video, that's it. So, take care.